Okay, in part one of my series of creating an acoustic guitar, on the fretboard design where we cut in the fret slots, I neglected to share all the information I should have. When we cut in these slots, the method that I showed to do that, in order to get a curved bottom in this slot, only works if you have hidden tangs like these. And we can see here that best way to do this is to select that face and then flip this around, find it, bring it back up here, and you can see that profile there is that the slot is curved on the bottom to match the top. However, this does not work if your tang is exposed. You'll get an error in Fusion when you try to select that object. And just to review how we did this is, in our extrude for this, we chose an extent type of toObject, and the object we selected was this face, and that caused the extrude to take on the shape of that face, thus giving us the curve on the bottom. However, if we have exposed tangs, we get an error. And, just to review that, I'm going to go to my parameters. I'm going to change my tang offset to a positive number to create the exposed tangs. So the way we do that, and there seems to be a little glitch in here. When I update these parameters, it does not update here. That's a problem for another day. I'm not going to get into that right now, but if we go into the sketch for that profile, all we have to do to fix it is double click on the offset and hit OK, and it fixes it. And hit OK on both the top and the bottom, and now our offset is to the outside the way we want it. When we click OK, our extrude broke. And it broke because when you try to extrude this surface and your profile is outside that body, you get this error that it can't extrude it. And there doesn't seem to be any way around that. So to fix that, we have to, instead of choosing that face object, we're going to delete that object, and then to fix it we have to come down here and choose a point here at the corner on the top of that fretboard like that, and now it'll extrude them. But the net result is that we lose that shape of the top. So if we go in here and choose that face, and then oops, let's get that, and then come in and look at that, you can see that it has a flat bottom now instead of a curved bottom. So that's a quick review of what we're going to solve here. So now I'm going to show you what I've come up with in order to create a parametric cut on this slot that works both for exposed tangs and hidden tangs, and gives us that curved bottom that matches the curve on the top of the fretboard at any point along here, remembering that potentially, and in this case it is, this is a compound radius. It starts off at a 12-inch radius on this end on this particular model, and on this end it's down to a 16-inch radius, or up to a 16-inch radius. And so every one of these slots has to be a different curve to match the difference in the curve on the top. So with that said, let's get into how we're going to solve this. So first thing we need to do is we need to review our nut radius and our heel radius to make sure that they're set up right. In fact, we need to make a modification to that. So let's go into the heel radius, which is probably not well named because it's really not the heel radius, it's the radius at the sound hole. So this is what our sketch looks like. Let's turn off that body so we can see it better. Some important things to note is that, why isn't this, no, that's not constrained. Let's make sure that's constrained. Let's get that constrained to, no, there's no point there to constrain it to, that's the problem. So I'm going to need to create a point real quick here. So right there, I'm going to create a point over here as well. And then I'm going to constrain this to this. That's important. This one's probably over constrained, yeah. So now that's fully constrained. But in our original drawing, we don't have this extension on the end. So just to review what we need here. In fact, let's just delete some of this and redraw it. We've projected in, I'm going to make that a construction line, our body. So we bring in our body and we're going to project in this top and bottom line. Okay, and then turn the body back off. And then we're going to create a construction line from see, ideally this would have been up here. Well, maybe it is because this is covering it, but this construction line, let's delete that and just redraw it. We're going to make a construction line from this point to this point. And we want the same over here. We'll make sure that construction line goes from this point to this point. Okay. Delete that point. Okay, so now that this is free floating again like it was before. And what we're going to do is we're going to create a 3-point arc. I'm just going to create it in space here for the time being. Don't want it to be construction. First thing we want to do is make sure that it is constrained to the midpoint of this upper body of the fretboard body. So it's midpointed. Next thing we want to do is make sure that it is tangent. That's what's going to ensure that this side where it intersects is going to be the same on both sides and even. So that's really important, both a midpoint and a tangency on that arc to that upper line. Next thing I want to do is I want to give this the radius. And right now we're working on the heel radius. So we want to use our radius parameter for the heel, fretboard radius heel. And then we want to put a length limit on this. And what I want is I want this arc to be my width at the heel, so my heel width, and then I want to add another 1/2 inch to that to get some wings out there on the side that we're going to use in a little bit. So I'm going to add 0.5 inches to that. That'll give me a 1/4 inch on each side on the outside. Okay. Then I need those points so that I can reconstrain my box on top. So I want to come to this intersection right here and put a point there. And I want to put a point here. And then I'm going to make these coincident to those points. Okay? And this is going to be coincident to that point. Okay? So this is our completed nut profile the way we need it to be in order to implement this new technique of cutting our parameters. And then we're going to flip this around to the other side and do the nut radius. And let it recompute here. Okay, and that broke our extrude, but we're going to fix that in a minute. So next let's go back to our nut radius sketch. I'm going to turn off the heel radius, get it out of our line of sight. So again, it's the same thing. We're going to project in this, turn off the nut radius thing, and we want to make sure this is projected in and this bottom line is projected in, and then you can make them construction lines to keep them from getting in the way of your loft you're going to do. Okay, so turn back on the nut heel, and it's all the same constraints. So again, you want to make sure that it is both midpoint and tangent to that upper line. You're going to make sure that this is constrained to that point and this point. Same thing on this side, your width is going to be the nut width plus 0.5, and your radius is going to be the nut radius, fretboard radius nut. Okay, so that was just a review to make sure that these are set up right, because that's critical. Okay, so we have that. So we're going to go back into this. This is the extrude for the inlays. So if you didn't do these inlays, it's not important. I'm just going to go fix this real quick because we changed those lines just now. It kind of messed this up. I just need to make sure it took away the object that I was. So all I need to do here is reselect my object and say OK, and it will fix my inlays. Let it recompute. Okay, so now what we're going to do, I'm not going to go back and re-review, but after we did our nut radiuses, we did a loft that created the cut on the top that gave us this shape. I guess I can jump in and just look at that real quick so we can remember. So I used that radius I created from this side to this profile, and that cut in my compound radius on the top of the fretboard. Okay. And then after that, we created our plane up here on top in order to draw our sketch of our frets. And then we drew our, I'm sorry, let me get out of there. I'm going to skip over the inlays. So we drew our inlays on that plane, and then we extruded them in, and then we basically got them out. And then we get to this point right here where we've created our fret grid on top by projecting in the fret lines that we calculated early on in the design in the first sketch. Okay. So I'm not going to review all that. I'm just going to start from where we were. So we had this. And then in the old way of doing this is we did a thin extrude off of each one of these lines in order to cut our frets in, which looked like, we already looked at that a minute ago, but let's turn back on that thing. And so it cut these in with that flat bottom. So to fix that, what we're going to do is we're going to let's just back up behind that, and we're just going to go to the sketch. So instead of drawing in these lines like we did here, and before, remember, we had this to the inside to make sure that we could get these constrained properly, and then we moved it to the outside for an exposed inlay. But what we're going to do in this case, it doesn't matter if it's on the inside or the outside. We're going to not draw these. We're going to delete all of these lines that we drew in, or if you're starting from scratch, you will never draw them in. Up to this point, though, you are going to do all the extrusions just like in the original video. Not extrusions, projections, I'm sorry. We're going to project in all those fret lines. We're going to project in our the side of the body right here. This was projected in from the body. Okay, that's that line projected in there, and we projected in all of these and made them all into construction lines. And then we did our offset from this line using our tang offset. Okay, same down here. offset on the bottom side to our tang offset. Now in our parameters, that could be a negative number or a positive number. Right now it's set to positive, which takes it to the outside. If I change this to negative, it would bring that offset to the inside. Okay, that's a lot of review, but that's it. So we deleted those lines, and now we're ready to start with our new design. So what we're going to do is we're going to draw 2 lines for every fret. And when you draw these, you want to try to be careful that you don't let it create any automatic constraints. Like here, if I did this, it would put a perpendicularity on there, and we don't want that. You want these lines to be free of any constraints. We're going to put in a parallel constraint on them later. So make sure when you draw them, or otherwise you'll have to go in and delete them like that. So we're going to run down the line here and draw a line on each side of every fret. And try to offset them. We'll see. Yeah, I just accidentally created a constraint there. You're probably not going to be able to avoid that completely, so I guess you just accept it. And oops, I'm drawing them to the wrong line anyway. Control Z, 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 Z. Make sure you're drawing them to the outside, to your offset lines, whether they're inside or outside. Make sure you're drawing them to your offset line. And if you accidentally miss, you'll be able to tell here. So if you miss like that, you're going to have to go get a coincident and make that coincident. All of these. I failed to connect them. Get them. Make sure you see that X right there. See, I don't know if you can see that in the video, but make sure you see that X, and then you'll know that it's constrained to that line. And there again, I created a unintentional constraint. Okay, once you got all those lines drawn and you've made sure that they're all coincident, if you see any of those little white circles like that, then that means that it's not constrained to that line. Make sure that they're all constrained to the correct line, your offset line, not your construction lines. And then and make sure you get rid of any inadvertent constraints that were put on like that. And then you're going to get your parallel constraint, and you're going to make each one of these parallel to its fret line, like that. Remember, these frets in this design, you can have a different scale length on high E versus low E, so these frets aren't necessarily parallel to the side of the thing. They can be angled if you choose to design a fretboard that has got a different scale length on low E versus high E. So that's why we want them parallel to that fret versus perpendicular to the side of the fretboard. Got them right, you should see this pattern of 3 and 1, 3 and 1. Some of these I didn't get quite nailed down right. Okay, got those all set now. So then the next thing we need to do is put a dimension on each one of these lines. And to make it as easy as possible, we're going to put the first one on. We're going to dimension this to that center line, and that's going to be our tang offset, not our offset, our tang width, sorry, divided by 2. So we're going to put that in there, and then we're going to highlight that and do Control-C and copy that, and then hit enter. And then we're going to do that same thing. Make sure you get in that center line. Don't dimension it to the other side of the tang width. You want to make sure that it's to that center line. And Control V to paste that in there and hit enter. And you just go down the line. So this is a lot of work, but it'll be worth it in the end because it'll work in whatever, and it'll be fully parametric. Of course, by parametric, I mean that if you change your tang offset or your tang width or your tang depth, any of that stuff, it's going to propagate it. You won't have to go mess with the model. It'll all right. Boy, I don't know about anybody else, but that kind of repetitive going down the line doing the same thing over and over again makes me crazy. I'm just reviewing them now, making sure. I should see my parallels here. I should see 3 with a double one in the middle, straight down. I should see, you know, my lines are all look like they're in the right place. Go all the way down the line and just double check and make sure I didn't get anything wrong. Okay. So now that we have that, we're going to finish sketch. Turn back on our body for a moment. And then what we're going to do is we're going to turn on our heel and nut radius sketches. We're going to turn off that body. Actually, we're going to leave on our bodies, but just turn off the fretboard. And I'm going to go ahead and turn off all of my inlays as well. I'm going to hide them. I don't want them interfering. So now this is where we're going to use those extensions we put on. We're going to do another loft here, but we're going to do a surface loft. And we're going to loft between this line and this line. We want to create a surface body that is extended past the side of our fretboard body, like that. That's what's going to allow us to get a, I think, oh, I forgot your name, I'm sorry, but one of my commenters called it a faux fret. That's essentially, I'm going to create a faux tang is what I'm going to do, sort of. This is just going to be a surface body that is the width of my tang, and we're going to cut that down. So these bodies I'm creating are used, this one is going to be the source of our faux tangs, and then I'm going to create some other bodies here that are going to be just cutting tools. So let's turn off that fretboard body again, and let's turn on our fretboard inlay, not our inlay, our frets, I'm sorry. And now what we're going to do is we're going to do an extrude, a surface extrude. We're going to select that line and that line, and we want it to be a new body, and we're going to do these separately from the others because we want to make sure that each one of these is its own body. So what I want to do is I want to extend that down through this surface so that it cuts through the middle like that. They're going to be cutting tools. Okay. And that'll allow me to cut that now to the size of my offsets, not to the size of the fretboard. If we look at the fretboard, it's sitting inside here. But this is going to let me cut those to of my offset. Okay. So turn off fretboard body again, and then what I need to do is I need to create a cutting tool on each one of these lines. So now we're going to select an extrude, and we're going to select every one of these lines. I'll try to anyway. Okay, we have all those selected. The number should be 40 for a 20 fret, so I know I've got them all selected because I've got the right number here. I'm going to do a extrude now down through all of that. Okay. Click OK. Make sure that was new body. So now every one of these cutting tools is a body. Okay. So now I'm going to do a couple of split bodies. Split body. My surface to split is here. First thing I want to do is cut off these outsides. So I'm going to select my splitting tools as these surfaces here. If I can make sure I'm grabbing it. There we go. Okay. Oops, it said it gave me an error. Why? Okay, so I did something. Let's try that again. I'm not sure what I selected wrong. I selected something wrong. Okay, so I'm going to select that body, and then my splitting tool is going to be that and that. And say okay. Okay, at that time it seems to have worked. So now what I want to do is I'm going to delete my excess bodies. I'm going to select both those outside cutting tools, and I'm going to select these bodies that it cut off and leave my centerpiece. Oops, I let go of things, so I lost right there and right there. And then hit the delete key and delete those faces. Okay. Now what we're going to do is we're going to use all of these as cutting tools to cut through this, and what's going to be left is our faux tangs. Okay, we're going to do a split body using these as our cutting tools. I'm sorry, we need to choose our body to split right here. And then I'm going to turn that body off to make it easier to select my cutting tools. So we're going to select cutting tool here, cutting tool here. I'm just going to do one. Normally I'd select them all and do it, but I just want to show. Let's turn back on that body, and let's do a cut. And then what we should be able to do is delete that, delete that, delete that, and I'm going to temporarily delete this. I'm going to undo that in a minute. And you see what's left here is our faux tang. Okay, now I'm going to quickly go do all the rest of them. Let me turn that back on. I'm just going to modify my split body. Actually, I'm going to put these back and modify my split body, and I'm going to go down and select the rest of my cutting tools here. Here. You can see this is a little challenging to grab these, but just be patient. Make sure you get that surface highlighted. When you get down to the end, you should have 20, well, I have 21 because I already selected the back side of one. So now you can see that you've got something's wrong here, because I should have surface selected here. There it is. I don't know why it was hidden from me. Each one of those has a cut plane on it. So now we're going to turn it the other way, and what we want to see is like this one where we've got a double. So we're going to select the back side and got a cutting on that side, on that side, on that side, on that side, on down the line. 40 cutting tools. Make sure that body is turned back on that we're going to cut, and click OK. Now we should be able to go in here and select all of these. Make sure you don't select anything else by mistake. You want to make sure you just select these and hit delete. And that'll leave you with these. So then you're going to go down and select those faces. Again, making sure you're only selecting those faces. No, none of these lines. In fact, turn off your sketch if you got more sense than me. And that way you won't be so liable to select the wrong thing. Be careful you don't select this middle line, because that is your surface you're trying to save. So make sure you're selecting just those faces. I'm going to delete that side, and I'm going to flip it around, and I'm going to run down the line and delete the other side. Normally I would do it all, but because I don't like to get a bunch of stuff in my timeline when one timeline item will suffice. Delete. And there we go. So there's all of my faux tangs. If I turn my body back on now, my fretboard body, those are sitting right there on the top. They're kind of blended in with the top a little bit. I'm not quite sure why, and that's going to create a little adjustment we got to make. But what we're going to do now is we're going to select each one of these, making sure we're getting that thing, and we can turn off our fretboard again so we can select them. I want to select every one of them. Come on. If they'll cooperate, I'm going to select them. Get big enough. There we go. Okay, so I'm going to select the first one, and then I'm going to do a thicken. And then I'm going to go down the line and select the rest of them. I think now that I'm in the thicken, I can select them easier. Okay, my count is 20, so I'm pretty sure I got them all. And then what I want to do is I want to make sure I turn back on my fretboard body that I'm going to cut. And notice how those tangs extend past the side of the body. That was what was important. And then for my thickness, I'm going to choose my tang depth. Tang depth. And because this is, I want to make sure it cuts through the top as well. Here, I'll do it without it, and you'll see what happens. Is I click OK, and then I want to. You can see. Oh shoot! I'm sorry. Let me fix something. That thicken is supposed to be a cut, not a new body. There you go. Okay, so there. Now click OK. Now you can see that I've got my tang in there, but I've got a thin skin still on top. So back inside that thicken, I'm going to simply do a symmetric cut so that it cuts both directions, so it cuts up and down. I'm going to change this from one side to symmetric and say OK. Okay. And that's it. We have that. So now if we want to prove to ourselves that that's a curve, we're going to come back in here. We're going to select that face. We're going to turn this to the left. I'm going to zoom out and find it and bring it up in here. And now we can see that on our offset to our exposed tang, we have our curved surface on the bottom. Now, we want to prove to ourselves that this is parametric, so what we're going to do now is we're going to, I'm going to go ahead and, this particular extrude right here is the one we did with our thin. So we're going to delete that extrude, and then these last two items are just cutting in our sound hole. So what I'm going to do now is I'm going to go and change in my parameters. I want to turn this to an inside tang, a hidden tang. So I'm going to come in here and change this to a negative number, my tang offset. I'm going to save that and go back to my fretboard and update the fretboard. Now I still have that problem in here that I don't know why it does it, but when I update my tang offset, this function doesn't update, and it should. And to get it to work, I have to just open it and save it. And see how it went to the inside? Got to find the one on the other side and do the same thing, open it and close it. I don't know why I have to do that. That seems like a bug to me. It's not picking up that update from the parameters. But anyway, I'm going to finish my sketch. It's going to recalculate, and you see now I have hidden tangs. And again, if I want to prove to myself that it's still curved on the bottom, I'm going to go select that face, if I can grab it. I'm going to bring this around. I'm going to flip it to the side. I'm going to zoom out and find it, and we can see that our profile, oops, I just deleted it. Okay, let's go back in here and grab that face again, bring it back to the face, and bring it up here, and we can see that our rounded bottom. So the last thing we want to prove to ourselves is that, you know, it's still parametric also on width. So once again, we're going to go to parameters. We're going to go change our tang width to, let's double it. Let's make it 0.046. Yeah, that doubles it. So and then let's save that, and let's go back to our fretboard. Let's zoom in, and what we should see is when we update this, that should double in width, and it did without any breakage. So I think that's it. I think that solves the problem. Now we have a model that doesn't matter if you're hidden tangs or if you're exposed tangs, it will cut the fret groove with the curvature of the top of the fret in the bottom of that slot. So thanks for watching, and I'll see you on the next one. So I think that's a pretty significant improvement on the model, especially for those of us that plan on using this to cut our fretboards on the CNC. So I hope that's helpful. Thanks for watching. Hit like and subscribe if you can, and I'll see you down the road.